Hey, this is a review on nuclear reactions. So it's writing the equations to show what happens when fission happens, fusion happens, alpha decay, beta decay. So if that's what you need practice on, which you probably all do, you're on the right video. You'll need this guy, unless you just want to take my word for it, but you need to know how to do this on the test, how to find whether or not things exist in nature. We're basically just going to go through things in the book, and so with that online textbook, page 78, it's the questions for lesson 15. We're going to look at some of the questions from lesson 16, but basically just practicing the things that we've been learning about decay. There's also a carbon dating video, or going to be one, if there's not one already, and E equals MC squared video, or there's going to be one if there's not one already. Alright, so number 7. We'll just do a couple of these. You can do the other ones on your own and come ask me like, hey, did I do it right? And if you did, then yeah. So these are going to be undergoing beta decay. They emit a beta particle. So you give the name, you give the symbol. Now on these, the best way for you to learn and make sure you're doing it right is for, I just read the question just now, so you pause, you do what you think you're supposed to do on it, and then unpause, watch me do it, see if you got it right. That's going to be the best way for you to see if you're doing it okay. And if you're wrong, you can make the adjustments there. So for this one, I hope it didn't freak you out if that flashed up on your screen. I paused it and wrote the question. That way I waste less time writing, and so you have less video to look through. That undergoes beta decay, so that shoots out a beta particle. So you can fill in the numbers. It shoots out the beta particle plus something else. The key to not doing these backwards is to put an equal sign there. So 0 plus 42 equals 42. You wanted to say 19 minus 1, but because you put an equal sign there, you can't. You have to stop. So 20 minus 1 equals 19. Or you just remember, add 1 proton if it's beta. So you go from 19 to 20. That is element calcium. So now they want you to see if it lives on here in the island of stability. And so we can check that. You go over 20. You go up 22 neutrons. You do not go up 42. You subtract 22 neutrons. So look on here. This one turns out over 20, up 22 exists. You have a little box. So that means it exists in nature. We could find it if we dug around a bunch and had testing to do that. Alright, so next up, iodine 131. So pause it, see if you can answer it. Iodine 131, element number 53. It gains 1 proton, becomes 54. The mass stays the same because the neutrons and protons add up to the same amount. That is Xe. Now on both of these, you went from K to Ca. That's just over 1 step on the periodic table. For iodine to Xe, that's just 1 step on the periodic table. So 1 to the right is your answer for beta decay. So on this, same thing. Pause it, see if you can find the answer in the island of stability, see if it exists. So, over 54, up 77 on this graph, and you have a bunch of boxes there, so yes, it exists. Yay! They also wanted you on this to write the names. The name is just calcium, or you could write out the word calcium 42. The name for this is xenon 131. What's the mass number? 131. Easiest question I can ask you. So again, you can do C and D. Ask me if you're right later on, and I'll tell you if you got them right. For now then, let's look at, I don't want that. Let's look at next ones. Emitting an alpha particle. So, same process, but instead of shooting out a beta, we're shooting out an alpha. So first one, platinum 175. It's element number 78. So pause it, work it, see if you get it right. Alright, so you shoot out an alpha particle. So what you have before equals the alpha particle plus whatever's left over. Alpha, you can either write A or you can write the HE. The important thing is to remember to put those numbers. So you shoot out 4 pieces of mass from your nucleus, which means you only have 171 left. 4 plus 171 is 175. You shoot off 2 protons, which means you only have 76 left. And so that ends up being osmium. So pause, find osmium 171 on your graph, see if it exists. Alright, so over 76 on the graph, up 95. This writes horribly. You end up in no man's land. So that does not exist in nature. You cannot go out and find a bunch of osmium 171 because it doesn't exist anywhere. But a good try. Next up, gadolinium 149. Alpha decay, what's it make? So, gadolinium 149. Arrow, you put an equal sign, so you remember. I mixed it up this time because you can't hold me down. You can't make me write an A every time. I do what I want. So, I went with helium. Eat that. It's been a long day, sorry. 145 plus 4 equals 149. 62 plus 2 equals 64. So that is element SM. So just like with beta, you went 1 to the right every time because you added the proton. Here you lost 2 protons every time. So you go 2 spots to the left. So from platinum on the table, you go left 2 to get your osmium. From gadolinium, you go left 2 to get SM. Samarium. I'm guessing it's really far away from that table. So, again, pause, see if it's on this chart. Alright, so over 62, up 83 neutrons, and yeah, it's there. It's in a white box. White means it's radioactive, which means it's going to turn into something else to get closer toward the center of the island of stability. In general, after a while, it's 1.5 neutrons per proton. So 1.5 of 62 is about 80, give or take. So you can kind of ballpark it sometimes, but that's what it kind of ends up being. Just a side note for you. All right, the last question we're going to look at. I really like it because it's interesting, but they really screwed it up in the book. So platinum 197 undergoes beta decay. Its daughter isotope then undergoes beta decay. So what would it make? So if you have platinum, it undergoes beta decay. So that means it gains 1 proton. So from on the table, you just go over 1. That is now gold. It undergoes another beta decay. It really should have stopped on gold. And you get mercury. So 2 beta decays, you go over on the table twice. You go from, and this is where it's messed up, it's not 119 down there. I don't know where that came from. It's 78. So you go from 78 to element 80. So it would have to be that. The other thing they messed up, if it undergoes beta decay, the top number has a change of 0. So it still should be 197. So they screwed up the question, or the answers. I think it's a good question though. Is if you undergo beta decay twice, or if you undergo alpha and then beta, it's just stringing 2 things together. So that's all I have to worry about. I don't know, when I do an ink layer, it freezes my face, and then it just seems weird. So, alright. Alright, so now we're looking at lesson 16. We'll skip a couple of these because it's the same thing that we just did. Number 5. Nuclear equation for the formation of iron 54 through fusion. Fusion is where you take 2 little things, you put them together, make a big thing. It has a mass of 54. So basically, you're just adding stuff to make iron 54. Iron has 26 protons. So, see if you can fill in the blanks really quick. Alright, it really doesn't matter what you put. All you have to make sure is these 2 add up to 54. You can put whatever you want. These 2 have to add up to 26. You can put whatever you want. So you can put 1 and 1 and 53 and 25 if you want. It doesn't matter. All that matters is whatever you put in comes out the equals on the other side. Yay! In the next question, we're going to examine this a little bit. They start with adding a neutron to uranium-235. It holds for a second, or not even a second, but then it cracks it because it's too unstable at that point into all of these. And this is where we talk about a chain reaction, or if we haven't yet, we will talk about a chain reaction. So they ask on here, fission of uranium-235. That's what happens in nuclear power plants. Begins with the addition of a neutron to the nucleus. What isotope is formed? Give the isotope symbol. So, uranium-235, 92. You're adding in a neutron and then turning it into something. So, you need to think about real quick what numbers are going to go there and then see what your product is. So, if it's a neutron, it has 0 protons, but it has 1 proton or neutron. So those are the numbers on a neutron. Add them up to get 236, and it's still 92. So it's still uranium. It's just a different isotope of uranium. And it's enough energy to crack that into whatever we have going on next. So the next question. After the neutron's added, uranium atom is more unstable and undergoes fission. So now it splits. So we fuse and then we fizz. Possible set of products is krypton-94, barium-139, and 3 neutrons. How many protons are in these products? Alright, it shouldn't be too much of a surprise. If you put in 92 neutrons, you should get out 92 neutrons, so you end up with 92 neutrons, or protons. So it all ends up adding up to the same thing. So I think it should wrap up the review. Basically, difference between alpha and beta. Remember to put the equal sign there when you're using the arrow. Difference between fission and fusion. So if it's fission, 2 things, or fusion, 2 things turn into 1. If it's fission, 1 thing breaks down into 2. So thanks for playing. We'll see you next time.